Very good morning, one and all. My name is T. Rajita, lecturer in ECE, Government Polytechnic, Mamla. In third semester, I am dealing with network analysis. Now, I am going to discuss the topic Phasor representation of sinusoids. Today's class, after completing this class, we would be able to understand the direct current, alternating current, difference between alternating and direct current, and phase of alternating current and phase difference. So now what is direct current? Direct current is the current that flows in one direction only and has a constant magnitude with respect to time. See here, the time is going on increasing, the current is becoming, it's a constant. The current is constant. For example, in this figure, it is 1 amp and it is a straight line. Alternating current. Alternating current is a current which changes periodically both in magnitude and direction. This is the figure. It's an alternating current. It is also called as sinusoidal wave. And here the time is going on increasing. The amplitude, the voltage is going on varying from 0 to peak value and from peak value to 0 and 0 to negative peak value and again it is coming to 0. In this way, the voltage is going on changing with respect to time, or current is going on changing with respect to time. This is called alternating current. So, representation of a sine wave. A sinusoidal signal can be represented in three ways. A sinusoidal wave, already we shown in the last figure, it can be represented in three ways. One is mathematical form, two, graphical form, three, phasor representation. So the representation of sine wave in mathematical form. A sinusoidal current is represented by equation I is equal to Im sin omega t, where I is the instantaneous current, Im is the maximum current, omega is the angular speed in radians, t is the time in seconds. Means the current is varying from 0 to maximum value, that is Im, and with the angular speed omega, and it completes the one cycle in time period t seconds. See the graphical representation. This is the sinusoidal signal half cycle, and this is the another negative half cycle. So the red color is the positive half cycle of sinusoidal wave, and this blue color is the negative half of the half sinusoidal signal. See here, that is instantaneous value of the sine wave, and that is the peak value or maximum value, that is I maximum is the value. and it is also called as, this one is instantaneous value. And this is also, that peak value is also called as amplitude. And the total time period for completing one cycle is 0 to t, or this is the negative half cycle. So in this way, the current is varying with respect to the time. It is called alternating current. Whereas direct current is, the current is constant throughout the time variation. That is called direct current. In alternating current, the current is varying with respect to time. So at one time it is the maximum value, and another time it is the negative maximum, and some time it is becomes 0. So this is the sinusoidal wave representation. This is the graphical representation. So already we saw the mathematical representation, and now it is a graphical representation. And this also can be represented in a phasor form also. See here, the time completing for one cycle is 0 to 2 pi. Now I am going to explain about the phasor representation of sinusoidal waveform. A phasor is a vector rotating in counterclockwise direction. A magnitude is equal to the peak value of sinusoidal quantity. Angular speed corresponding to the frequency of signal. See here. In this way it is moving. The phasor, this is called phasor representation. For one complete cycle is one cycle. So this is the phasor representation for sinusoidal cycle. Now in this we can see here, it is a phasor. When the phasor is, but sine wave is at 0, the phasor is at 0 degrees. Production of sinusoidal signal for different positions of vector quantity at different instants is shown here. See, at sine wave at 0, phasor is at 0 degrees. And when sine wave is at 45 degrees, then the phasor is at 45 degrees. And when sine wave is at 90 degrees, the phasor shows at 90 degrees. And when 135 degrees, it is shown as at 135 degrees. And when sine wave is at 180 degrees, shown at 180 degrees. And at 225 degrees, it is shown at negative sign. And 270, the phasor is like that. And 315, see the phasor. And at 360 degrees, it is the phasor. So the sinusoidal representation, sinusoidal signal phasor representation is like that. So in important terms and definitions of a sinusoidal signal, the value of alternating current quantity at a particular instant of time is known as instantaneous value. So again I am repeating, the value of an alternating quantity at a particular instant of time is known as its instantaneous value. Already I shown in the last figure instantaneous value and peak value. The peak value of a sine wave is the maximum value of sine wave during either positive half cycle or maximum value of during negative half cycle. So RMS value. RMS value of sinusoidal voltage is 0.707 times the peak value. That is, PRMS is equal to 0.707 V maximum. See the figure. Differences between AC and DC. First, what are the differences between the AC and DC? First, the waveform is step voltage and straight line for DC. AC, it can be sinusoidal or sawtooth or square waveform. In the above parameter, step up or step down. Step up is not possible but can be reduced. But here it is possible. Direction. DC is unidirectional but AC is bidirectional and changes in regular intervals. Magnitude. Magnitude will be steady in DC and it varies between reversals in polarity. Induction. Induction is not possible in DC, but it is possible in AC. And AC to DC, DC to AC conversion is possible. Phase of an alternating current. It is the time period that has elapsed since an AC current last passed a given reference point, usually the starting point, is called its phase. It may be expressed in time measured in seconds, fractions of time period, angle expressed either in radians or degrees. See here, there is a two sinusoidal waves are coming. Here, this is in time, omega t. The phase can be represented in omega t or theta. Here, the theta means the sinusoidal is going on varying. That time can be represented, that phase can be represented in 0, 90, 180, 270, 360, like that we are showing that. Here, for completing one cycle is 360 degrees. The phase can be represented in degrees. And a phase also can be represented in radians. That is 0, pi by 2, pi, 3 pi by 2, 2 pi. For completing one cycle, 2 pi radians is required. So, for one cycle, the phase can be represented in 0 to 360 degrees and 0 to 2 pi degrees, or 0 to t is the time. In three ways we can represent this. It can be time, it can be degrees, it can be radians. Sine wave can be represented graphically by a straight line with an arrow. The length of the arrow represents the magnitude of phasor. It also indicates the direction. So, a sinusoidal wave can represent a length of arrow with its direction. That is called phasor form. See, this is the thing. Here, 0 to O to P. OP is the phasor. A length OP represents a magnitude A. And phi is the angle made by phasor A with the reference axis OX. So OR, RP are phasors and their magnitudes are OR and RP respectively. See here, there is a three phasors. OP is a phasor, OR is the phasor, RP is the phasor. In this, OP is the magnitude is A and angle is phi with respect to OR. And for OR, there is a magnitude is A1 and the angle phi is 0 itself. And for A2, for RP, there is a magnitude is A2 and the angle is 90 degrees. So here there is a three phasors, that is OP, OR, RP. See here, again I am showing the same figure as a sinusoidal. See, the phasor is at 0, 0 and the phasor at 45 degrees it is like this, and again it is 90 degrees like this, again it is 135 degrees is like this, and 180 degrees is like this, and 225 is like this, minus 225. So 270 degrees, 315 degrees, 360 degrees. So this is the phasor representation of sinusoidal. So different forms of representing phasors. It can be represented in rectangular form, trigonometrical form, exponential form, polar form. And this is the phasor OP, already we discussed, OP, OR, RP. And this can be represented in different forms. This OP can be represented as A1 plus JA2. Means here A2 is the phasor and with 90 degrees. This 90 degrees can be represented in imaginary term A1 plus or plus JA2. OP is the phasor, that is A1 plus JA2. This is complex notation and it is called as rectangular form. Can I explain again? See, the OP is the phasor and OR is the phasor along the x-axis and RP is the phasor in imaginary, like means it is vertical to the x-axis, that is in y-axis, and the phase difference between x-axis and y-axis is 90 degrees and the phasor OP is having a phase difference with respect to x-axis is phi. So the OP can be represented with the addition of OR plus RP. OR plus RP will give the OP. So that can be represented as A1 plus JA2. This is the rectangular form. And in trigonometrical form, we can easily write that by using Pythagoras theorem. This hypotenuse is equal to A1 cos phi plus JA2 sin phi. This all of you know this, and so we can write A is equal to A cos phi plus A sin phi. This is the trigonometrical equation. So in exponential form, we can write it as A e to the power of j phi. See, again I am representing that. I'm sure the OP is the phasor that can be represented in A1 plus JA2, that is rectangular form. OP is equal to A cos phi plus or minus sin phi. This is trigonometrical notation. And third one is A e to the power of J5, that is exponential form. And fourth one is A at an angular phi, that is polar form. So, any sinusoidal signal can be represented in rectangular form, trigonometrical form, exponential form, polar form. These are very important for doing problems in future. So, generally for doing the problems, we have to use this rectangular form, and polar form is regularly we have to use this solve the problems. So, addition and subtraction of phasors. So, let A, B are two phasors. A is equal to A1 plus JA2. B is equal to B1 plus JB2. So, how to do the addition of A and B? So, in this addition, the real parts will be added and imaginary parts will be added. So, it is A is a vector or A is a phasor. It is equal to a real part A1 is there plus JA2, that is the imaginary part. Okay? A phasors all are represented in complex notation. In a complex notation, A is equal to A1 plus JA2 and B is equal to B1 plus JB2. In addition of these two phases, we have to add the real parts and we have to add the imaginary parts. And we cannot add an imaginary part to the real part. So, in this, see here, when A plus B, A phasor A plus phasor B is equal to A1 plus B1 plus J A2 plus B2. In this way, we have to add that. And similarly, we have to subtract means A minus B is equal to A1 minus B1 plus J A2 minus B2. Like that, we have to add or subtract the phasors. And the outcome is another way phasor, that is C. C or D or whatever it will be the anything. The outcome is another phasors. By adding two phasors, the outcoming is another phasor, or subtracting two phasors, the outcome may be another phasor. This is the addition and subtraction of phasors, or a sinusoidal way. Similarly, now I am going to explain a multiplication and division of phasors. See here, let A is equal to A at an angle of phi. So, in the last slide, we discussed about addition and subtraction. We used only a rectangular form of the phasor. So, in a rectangular form, the addition and subtraction is very easy. And in multiplication and division, we have to use the phasor in polar form. See here that let A is equal to A at an angle of phi. That is equal to A is equal to e to the power of j phi 1. A at an angle of phi is represented as polar form. A e to the power of j phi 1 is represented as exponential form. See, B is equal to B at an angle of phi, B e to the power of j phi 2. It is the exponential form. A is the phasor, A at an angle of phi is the polar form of the phasor A. A e to the power of j phi 1 is the exponential form of phasor A. Similarly, B at an angle of phi is the polar form of B phasor, and B e to the power of j phi 2 is the exponential form of phasor B. So, now we have to multiply our division these phasors. Now we are considering the multiplication of phasors A into B. See, A into B, that is A at an angle of phi into B at an angle of phi. So in this, A that also we can write A e to the power of j phi 1, B e to the power of j phi 2. So here the two magnitudes can be multiplied and here the angles are added now. That is equal to AB e to the power of j phi 1 plus phi 2. AB e to the power of j phi 1 plus phi 2. This also we can write that AB at an angle of phi 1 plus phi 2. A phi 1 plus phi 2. Similarly, we can subdivision this phasors. So A by B, A phasor by B phasor is equal to A at an angle of phi by B at an angle of phi. So here this can be represented as A e to the power of j phi 1 divided by B e to the power of j phi 2. So this can be represented by A by B e to the power of phi 1 j phi 1 minus phi 2. A by B e to the power of e to the power of j phi 1 minus phi 2. So in this way we can multiply or divide the phasors. So what is the phase difference? When the sine wave is shifted left or right with respect to the reference, there occurs a phase shift or phase difference. It is very important to know this phase difference because we are using a future resistors, inductors, capacitors, and there is a phase difference occurs when the alternating current is flowing through capacitors and inductors, so that there may be a phase difference occurs. So that is the reason we are going to discuss about this phase difference, and phase difference is the sine wave is shifted left or right with respect to the reference, there occurs a phase shift or phase difference. See here, for a resistance, the voltage, and here see two voltages A and B, two phasors A and B, both are in same phase. That means these two phasors are starting at 0 itself. It is the two starting points of the two phasors is at 0, then there is no phase difference. From figure shows the phase difference is 0 because the two AC signals A and B are in phase. See in this figure. In this, the two signals A and B are not started at 0. There is a phase difference between A and B phasors is phi. So, there is a phase difference phi between A and B. See here, there is a two waves, CM waves, and one is started at 0, another is not started at 0 and at an angle of 0, and there is a phase difference between the two waves. Here E1 is equal to Em sin omega t and E2 is equal to Em sin omega t minus phi. See, there is a wave is starting at 0, starts at 0, that can be represented at sin omega t. When the wave is not started at 0, it is starting at 5 degrees, then the wave can be represented Em sin omega t minus 5. So that is clearly shown in the figure the two waves, one wave is started at 0, another wave is started at 5, the two waves are represented like that. See here, the first one, E1 is Em1 sine omega 2 and E2 is equal to Em2 sine omega t minus 5. So E1, E2 are the same frequencies, but there is a phase difference. But these two waves maximum and zero values at different instants. Hence, they have phase difference between them. All of you understand this phase difference? So the phasor diagram. Different sine waves of same frequency are represented by individual phasors indicating exact phasor relationship between them. A is equal to Em1 sin omega t, B is equal to Em2 sin omega t minus 5. Okay? These two phasors are phase differences there. Now the phasor diagram is Em1, Em1 sin omega t. Here it is starting at 0 so that the wave is represented in x-axis. If B is the sine wave, that is phase difference is 5 degrees, that is minus 5. So Em2 is represented, that is the phasor B is represented like that. Em1 is at, if it is not started at like this, when Em2 will be like this. Both are different. B lags A aithe, this one, and A leads B aithe, that one. See both the waveforms and the phase differences lagging behind and leading behind two phasors. So now we have discussed about direct current definition and analog current definition and differences between AC and DC and definition of phase and phase difference and phasor representation of the sinusoidal wave. So here we can represent the sinusoid because why we are using all these sine waves means in any laboratory, in anything, AC alternating current, we are testing or testing the devices or anything will be done in the sine waves only. Generally, we are using sine waves. So that is the reason for calculation, mathematical calculations or phasor calculations. For anything, we should know about the phasor representations and mathematical representations and trigonometrical representation of the sinusoids. It is very important to analyze the circuits. So this class only will helps the phasor representations. Now the quiz. Frequency of DC wave is which one? Frequency of DC wave is 0. Sine wave is represented graphically by phasor, complex wave. Graphically it is represented by phasor. The sine wave is represented graphically by Phasor. So the frequently asked questions. Define alternating current, direct current. Explain differences between AC and DC. Define phase and phase difference. Assignment. So convert the following complex numbers into the other forms. Here all phasors are given in rectangular form. First one is 3 plus j8. That in other forms means it can be in trigonometrical, it may be polar, it may be exponential. 15 minus j25, 25 minus j30, 220 plus j120. This has to be converted into the polar form. Simplify the following. Here, a rectangular form, that is 3 plus j8 plus a polar form 8 plus angle 75 into 10 e to the power of minus j60 divided by 10 to the power of exponential e minus j60 minus 15 minus j25 into 8 at an angle of 750. See here, there is 3 types of forms are there. One is polar, another rectangular and exponential. So you have to add means you have to convert the polar form into a rectangular form and then we have to add that. Wherever the multiplication is done, the rectangular form must be converted into the polar form or exponential form. If wherever the addition or subtraction are there, the polar form or exponential form must be converted into a rectangular form. So that is the reason we have to convert one form to the other form. That is very important. A rectangular form may be converted into a polar form or polar form may be converted into a rectangular form. So the thing is that the addition and subtraction, the polar must be converted into a rectangular form and multiplication and division, a rectangular must be converted into the polar form. Thank you.